Hello, everyone. Today, we're taking a deep dive into the latest version of CET.SteelConnDesign, version 1.7. This update enables you to seamlessly create steel beam splice connections using Tekla. For a comprehensive guide on how to download and install our software, head over to our YouTube channel, contact us at civilengrtools@gmail.com. Assuming you've already got version 1.7 installed, let's dive in. In Tekla, Beam B1, B2, B3, and B4 have been created. Remember, for a beam splice connection, the top elevation of the two beams needs to be the same. The names of these beams are crucial because our software depends on them to establish connections. Next up, we'll fire up our system after launching Tekla. This is crucial as it allows our software to link up with Tekla. Once our software is up and running, you'll see that the version number is 1.7. We apologize for any inconvenience caused by the inability to change some fields in the previous version, but rest assured, we've resolved this issue in the current version. In the connection setup, you'll spot a new beam splice option. Choose this option and scan the Tekla model. You'll see 4 beams in the beams list and other beams list. Today, we'll be creating connections between B2 and B1, and between B4 and B3. So, we'll choose B2 from the beams list and B1 from the other beams list and create a connection named B2_B1. Similarly, we can create a B4_B3 connection to link beam B4 and B3. Moving on to the Connection Design tab, we now have 2 connections in the connection list. Let's design the B2_B1 connection. After the design, you'll see the beam splice connection created in Tekla as expected. You'll also notice the updated image for splice connections. Let's switch to the web splice connection and adjust the connection to the middle of the beam. You'll see the plate's location in Tekla has been altered. We can also undo the last change, and the connection will revert to its original position. Please remember that the splice plate is utilized by both beams. Changing the splice plate thickness will affect the connection design for both beams. Let's modify the plate thickness to 0.5 inches. In the To Beam tab, let's change the bolt column to 2. The Tekla model updates following our changes. Now, let's examine the connection properties within Tekla. We see that the splice connection number is 77. In the Web Bolts tab, you'll notice our system has automatically filled all the values for the user, saving a significant amount of time. Now, let's review the design summary. It's organized into 4 sections: beam, web connection, opposite beam, and opposite web connection. Connection flexural yielding and flexural rupture checks have also been added to the summary report. Next, we'll look at the detailed report. Here, users can check detailed calculations for connection flexural yielding and flexural rupture. The final segment will demonstrate how to create a beam splice connection with different beam sizes. We can select the B4_B3 connection and design it. After the design, you'll see the splice connections have been created between beam B4 and B3. Our software also supports a one-side splice plate. Let's select left side and design the connection. Now we can rotate the 3D model in Tekla to check the design results. you'll see only one side plate has been created. That's all for today. Thanks for tuning in.